Hello my cute pasangala. So definitely we are waiting for the physics exam. Innum one more day left, correct? So idhula we have to go for the formulas, we have to go for the laws, definitions, everything. Ena adu important. Quick mark kedikkiradhukku we have the only one option is this one. Okay. So ipo in the video la we are going to discuss all the important laws, definitions and formulas. So first what you have to do is you should like the video, share with your friends and also subscribe the channel. ஏனா physics இன்னும் முடியல. நாளைக்கு we have a long marathon as well. அதுக்கப்புறம் chemistry இருக்கு. So அதுக்கப்புறம் definitely biology இருக்கு. அதுக்கப்புறம் we have the Neet exam. So அதனால இந்த channel you have to subscribe. ஏனா good high quality academic videos you are going to get it from here. Okay. So இப்போ we are going to start from the first chapter. So இதுல we will be discussing each chapter separately and அதுக்கு முன்னாடி I just wanted to tell you one more thing. இப்போ you just need a quick revision. Okay. அப்படினா you can just go to the description box. அந்த description boxல என்ன இருக்கு? ஒரு link இருக்கு. அந்த first link இருக்கு. அந்த linkல click பண்ணா போதும் you will be getting an option to download a PDF. அந்த PDF தான் what I'm going to teach right now. Okay. So இப்போ if you need a last minute quick revision for the formulas and everything in the PDF மட்டும் போதும் you can go through it. Okay va? So இப்போ we are going to start the video. Okay. So first electric charges and fields. Okay. Electric charges and fields. In the electric and charge fields first we are discussing about the charge. Charge na enna? Yes, ஒரு matter oda fundamental property da charge. Okay, it is a fundamental property of a charge. And on the charge la we have studied few properties. Quantization of charge adula ஒரு equation important da Q is equal to NE. Okay, இது quick we are going to discuss all the formulas. Okay, so Q is equal to NE. N na it is nothing but the number of electrons or number of particles. E na 1.6 into 10 to the power minus 19. Okay va? So adukapram if you are just checking on it, you know the conservation of charge. So there might be a question comes, what is conservation of charge? And the name la irukku in the charge the same every time. We cannot create a new charge, we cannot destroy any charge. Okay va? Next the additivity of charges na, like the numbers we can add this charges. Okay va? Next the Coulomb's law. Coulomb's law na enna? And the law important da, you should know the mathematical format as well. Two charges separated by a distance r, then there will be an electrostatic force between them and the force is directly proportional to the product of the charges and it is inversely proportional to the square of the distance between them, and that is nothing but F is equal to 1 by 4 epsilon naught Q1 Q2 divided by R square. In the expression you should know illena problems difficult aga pore. Okay va? And idhula if we are not keeping in air or let's say in vacuum, appadina in the epsilon naught it will become epsilon m and the mediatoda permittivity. Okay, mediatoda permittivity. So appadina I can say that and the relative permittivity there is a new term we should study, or dielectric constant. Appadina I can write the what is a permittivity in the medium divided by permittivity of air. Appadina permittivity of medium I can say it as epsilon naught epsilon r. So you can replace appadina you will be getting in the mediatoda if we are just keeping the same charge with the same distance of separation in another medium. Now what will happen guys? The force 1 by k times agum. Okay, force reduce aga pore. The force it is going to reduce by 1 by epsilon r times. Purinjada? So you should know all this format, and the vector form kuda important. The vector form also you should know. F12 which is equal to k, or let's say 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Na you should keep R cap in the numerator. If you are writing R cube na you should write R vector. Adanda vector form kuda important da in the Coulomb's law. Okay va? So next we are going for the electric field. Electric field na it is nothing but the space between, or let's say the space of a charge which has its influence. Okay, இப்போ ஒரு charge இருக்கு, அதுதான் we are calling it as source charge. அந்த source charge ஓட influential area அதுதான் nothing but electric field. Okay, அதுக்கு ஒரு relation or ஒரு general formula இருக்கு, limit q tends to, or let's say q naught tends to 0, adukku I mean why we are saying q naught tends to 0, ஏனா we need to know in the source charge oda influence da we need to understand, correct ah? In the source charge oda we need to know the electric field, I mean in any of the point what is the force experienced due to this one, அதுக்காக தான் we are bringing a unit test charge. Okay, இப்போ வந்து இந்த test charge வந்து I mean if it is a bigger value என்ன ஆகும் yes definitely அந்த I mean இந்த test charge ஓட influence கூட இருக்கும். அதனால தான் we are saying limit q naught tends to 0, and the q naught oda value வந்து it should be very small. Okay, limit q tends to 0, f divided by q naught the electric field oda what is a general expression. For a point charge adu வந்து 1 by 4 pi epsilon naught q by r square. புரிஞ்சுதா? So next வந்து superposition principle, you can use it for electric field as well as for the force. Okay, so it is nothing but if I'm talking about a force or the net force experienced by a unit charge, okay, a force experienced by a unit charge na, I can say that whatever be the individual forces exerted by individual or let's say nearby charges on this particular q, okay, அதோட vector sum, அந்த word இருக்கணும் vector sum, ஏனா force வந்து vector quantity தான். So இப்போ வந்து I cannot, I mean இப்போ வந்து இதுதான் நம்ம charge q, இங்க வந்து q1 இருக்கு, அது வந்து exert பண்ற force f1 தான், and இங்க q2 இருக்கு, அது exert பண்ற force f2 தான். So I can't just simply go for f1 plus f2, அது வந்து wrong. Okay, அதனால தான் we are saying vector sum of f1 plus f2. Okay, f1 vector plus f2 vector. If there are more charges, we will go for plus f3 plus f4 etc. Same thing will happen for the electric field also. Okay, we will find the individual electric field exerted at a single point, and now we will be checking in the point la irukra field theriyano. Okay va, adukkaga in the point la we are going to place the unit test charge. அப்படினா இங்க ஒரு சார்ஜ் இருக்கு q1, q2 இருக்கு, q3 இருக்கு. So இந்த 3 charges வந்து இந்த 3 charges ஓட influence இருக்கும் இந்த single pointல. So we can just find the electric field due to q3, electric field due to q2, electric field due to q1, அதோட vector sum e1 vector plus e2 vector plus etc. புரிஞ்சுதா? Next வந்து electric field lines oda property da, adu vandu romba important da, I have written over here. Next vandu electric dipole na enna, yes, two charges, okay, two charges separated by a very small distance. Okay, as two charges equal and opposite, ipo vandu idu 2 microcoulomb na, idu vandu minus 2 microcoulomb. So two equal and opposite charges separated by a small distance the electric dipole. புரிஞ்சுதா? So அதுல இந்த strength denote பண்றதுக்காக we are going for dipole moment. Dipole moment na, it is a vector quantity, அதுக்கு direction இருக்கு, direction வந்து negative to positive. புரிஞ்சுதா? So இங்க வந்து we can say that in the dipole moment, as I mentioned, you can study this equation like this: the charge into the distance of separation. Okay, you can study this equation, distance of separation. புரிஞ்சுதா? So in the, I mean you might have studied like this, q into 2a. Understand what is 2a. 2a na enna, inga vandu minus q irukku, inga vandu plus q irukku. இந்த a na the distance from the center of the dipole to any one of the charge. Okay, அதுதான் வந்து a. So it is not like if I have mentioned in a question, it is mentioned the separation between them is, let's say 3. Okay, 3 units da. அப்படினா what you should understand, separation 3. அப்படினா q into 3 da. புரிஞ்சுதா? You don't take q into 2 times 3, அது வந்து wrong. அதனால தான் I'm telling you, study this equation for I mean we don't want any confusion. அதுக்காக தான் I'm telling you, you can just study this. புரிஞ்சுதா? So இதோட direction வந்து negative chargeல இருந்து positive charge. Okay va? So in the PDF கிடைக்கிறதுக்காக you can do one thing, you can just check in the description box. And the description box ல first link ல PDF link இருக்கும். அதுல வந்து you can click on the link and you can just go to download option. So you will be getting the PDF. So you can study at any time as well. Okay va? So இப்போ வந்து we understood electric dipole. Okay, next வந்து we should know the electric dipole. Due to the dipole, we have a field at any point, right? So ipo vanda we will be focusing on axial point as well as equatorial point. Okay, so in the axial line la vanda in the field order value vanda k into 2p by r cube. So I mean you have to you understand one thing. So whenever we are talking about the electric field, ange we have said 1 by r square. Ana dipole varumbodhu the order will increase one more. Okay, so ange 1 by r square na inga vandu 1 by r cube. Yena in the top illa p irukku. Correct ah? P na enna? Q into some distance. Correct ah? So dimension correct aganumla. So adanal wherever you are finding about the dipole, ipo vandu potential we know it is proportional to 1 by r. Ana dipole oda relation varumbodhu it is 1 by r square. Purinjida? So we can just remember this equation 1 by 4 pi epsilon naught q by r square the electric field. And the r ku one more, I mean we need to add the power. So ipo vanda we will be getting 2k into 2p divided by r cube. புரிஞ்சுதா? So next வந்து equatorial pointல வந்து it will be coming as kp by r cube. அது வந்து direction electric field and the dipole moment வந்து opposite directionல இருக்கும். புரிஞ்சுதா? equatorial pointல இந்த direction வந்து opposite இருக்கும். ஆனா வந்து axial lineல இது வந்து same direction. dipole-ஓட directionum electric field-ஓட directionum வந்து same. ஆனா equatorialல வந்து opposite தான். Okay, next வந்து இந்த dipole I'm just placing in a uniform electric field. அப்படினா there will be force experiencing at each end. அது வந்து QE. ஆனா வந்து அது cancel ஆகும். ஆனா வந்து we have the torque. Okay, and the torque oda equation என்ன? Force into the perpendicular distance. So இப்போ வந்து force வந்து QE, we know it, and perpendicular distance வந்து 12 sin theta. Whenever we are substituting it, we will be getting the torque வந்து P cross E. Okay, P na dipole moment, E na electric field. So we can say and the magnitude of the torque வந்து PE sin theta. அப்படினா you can tell the maximum torque will be when theta is equal to 90 degree. Okay, when theta is equal to 90 degree na sin theta வந்து 1. அதுதான் sin theta ஓட maximum value. So when theta is equal to 90 degree, we can say that in the torque வந்து maximum. And minimum வந்து when it is 0 degree or 180 degree. அதுதான் it is given over here. Okay, இப்போ வந்து இந்த dipole moment and electric field வந்து parallel na what will happen? And the torque வந்து minimum. Maximum ஆகிறதுக்கு it should be the dipole moment and electric field should be perpendicular to each other. So next வந்து we are going for the electric flux. Okay, so first வந்து electric flux என்னன்னு தெரியணும். electric flux na very simple தான். அது வந்து electric field lines மட்டும் தான். ஆனா வந்து it will fall, or let's say it will passes through the surface perpendicular to the surface. Okay, while it is going, if it is perpendicular to the surface, and the electric field lines the whatever we are calling the flux. The total number of electric field lines passing normally through a given area is known as the electric flux. Flux na flow. அவ்வளோதான். ஓகே, ஃப்ளக்ஸ்னா ஃப்ளோ. ஸோ எலக்ட்ரிக் ஃப்ளக்ஸ்னா இந்த எலக்ட்ரிக் ஃபீல்டோட ஃப்ளோ. ஓகேவா? எலக்ட்ரிக் ஃபீல்டோட ஃப்ளோ. ஸோ எலக்ட்ரிக் ஃபீல்டோட ஃப்ளோனா என்ன? இங்கே there is only one point you should remember. அது வந்து it should passes through the surface perpendicular. ஓகே, அது மட்டும்தான் இருக்கு. Next வந்து we should know the expression. So அந்த flux வந்து it will be equal to E dot A. Okay, flux வந்து scalar quantity தான். Okay, scalar quantity தான். அதோட value வந்து E dot A, which means flux வந்து depending upon electric field, area vector as well as the angle between them. So இப்போ வந்து இது uniform இருந்தா you can say EA cos theta. இப்போ வந்து இது non uniform னா அந்த expression வந்து closed integral E dot ds. புரிஞ்சுதா? closed integral E dot ds, or let's say you can say E dot ds, or let's say E ds cos theta. புரிஞ்சுதா? next வந்து Gauss's law. Gauss's law na என்ன? closed integral E dot ds is equal to 1 by epsilon naught times the charge enclosed. The total flux passes through a closed surface is nothing but 1 by epsilon naught times the charge enclosed. புரிஞ்சுதா everybody? It is nothing but 1 by epsilon naught times the charge enclosed. So எப்பவுமே Gauss's law apply பண்றதுக்கு you should consider a Gaussian surface. Gaussian surface na it is an imaginary surface. அது வந்து 3 dimensional இருக்கணும். Okay, you can choose any shape. Okay, அந்த ஷேப்புக்கு அங்க இம்பார்ட்டன்ஸே இல்ல. புரிஞ்சுதா? அந்த ஷேப்புக்கு வந்து there is no importance in this. ஆனா வந்து it should be 3 dimensional and it should be a closed surface. புரிஞ்சுதா? And area vector ஓட direction you should know it will be always perpendicular. இப்போ வந்து applications of Gauss's law ல first we will be finding the electric field due to a infinitely long wire. அது வந்து k 2 lambda divided by r. Okay, so you can just go for either you can go for this equation or whatever I said, because ஏனா we are just multiplying it with 2 by 2. So அப்படினா we will be get in terms of k. So remember பண்றதுக்கு அது வந்து கொஞ்சம் ஈஸியா இருக்கும். ஓகேவா? So இப்போ வந்து we will be getting lambda by 2 pi epsilon naught r, or let's say 2k lambda divided by r. So you can also go for that. Okay, so electric field due to this will be coming as 2k lambda divided by r. இப்போ வந்து we have a plane sheet. Okay, infinite plane sheet. அதோட electric field வந்து sigma by 2 epsilon naught. Sigma na என்ன? Surface charge density. Okay, surface charge density na என்ன? Q by A. Okay வா? இங்க lambda என்ன? Linear charge density, which is nothing but Q by L. Charge per unit length. Okay வா? Next வந்து for a spherical shell. For a spherical shell, what will happen? There we have to consider 3 points. அது வந்து derivation ஆகும். You can expect all this question applications of Gauss's law. So இப்போ வந்து we have a sphere. இதுல வந்து we are taking it a point outside. So அப்படினா இது வந்து எக்ஸாக்ட்டா அந்த பாயிண்ட் சார்ஜ் மாதிரியே இருக்கும். ஓகே, பாயிண்ட் சார்ஜோட எலக்ட்ரிக் ஃபீல்ட் என்ன? kq by r square. கரெக்ட்டா? சோ இதோட இந்த ஸ்பியர் அவுட் சைடு வந்து சேமா இருக்கும், kq by r square. சர்ஃபேஸ்ல வந்து இந்த r will be equal to capital R. கேபிட்டல் r னு என்ன? இந்த ஸ்பியரோட ரேடியஸ் தான். ஓகேவா? நெக்ஸ்ட் வந்து இன்சைட் வரும்போது அங்க மாஸ் இல்ல, மாஸ் சார்ஜ் இஸ் ஆல்வேஸ் associated with the mass. மாஸ் இல்லனா சார்ஜ் இல்ல. சோ அதனால ஃபீல்ட் வந்து 0. புரிஞ்சுதா? So next வந்து continuous charge distribution. We have already discussed about this. Lambda வந்து Q by L da, and sigma வந்து Q by A, rho வந்து Q by V. So next வந்து we are going for the next chapter, electrostatic potential and capacitance. Okay வா? So in the chapter first we will be studying about potential and potential energy. Potential na enna? Whenever we are doing any work, okay, I'm just talking about the potential energy. We are doing a work against any conservative force na, adu vandu ennaga store, I mean it will be stored as the potential energy. So I mean in the case la vandu in the conservative force na electrostatic force. Okay, so ipo vandu we have a positive charge over here. Okay, and I wanted to bring a charge from infinity to a point which is at a distance r. புரிஞ்சுதா? We have a source over here, or let's say we have a charge over here. In the charge we have to keep one more charge near to it, and the distance must be r. Okay, so அதுக்காக infinity la irundha I'm just bringing a charge. And you know this is a positive charge and this is also a positive charge. அப்போ வந்து repulsion இருக்கும், கரெக்ட்டா? So in the electrostatic force வந்து it is doing a work like this, கரெக்ட்டா? It will repel like this. So in the electrostatic force ஓட direction இப்படி, ஆனா வந்து what we are doing, we are bringing the charge from infinity and we are doing against work done, correcta? In the work done we are against with the electrostatic force. அப்படினா அந்த work done da stored as the potential energy. So potential energy na, whenever we are taking a charge from infinity to a point which is at a distance r from a charge q, then the work we have done against the electrostatic force is stored as the potential energy. And ipo vandu whatever we are taking from the infinity and the charge vandu unit charge irundhucha, we can say that adu vandu nothing but potential. Adudha in the two terms oda difference. Okay, work will be stored as the potential energy and the work per unit charge da potential. புரிஞ்சுதா? ஓகே, சோ அதோட யூனிட் வந்து பொட்டன்ஷியலோட யூனிட் வந்து வோல்ட், ஆர் லெட்ஸ் சே we can say ஜூல் பர் கூலம். ஏனா பொட்டன்ஷியல் எனர்ஜியோட யூனிட் வந்து ஜூல்ஸ், ஆர் வர்க்கோட யூனிட் வந்து ஜூல்ஸ், சார்ஜோட யூனிட் வந்து கூலம். ஓகேவா? So இப்போ வந்து we have discussed about the potential, and for a point charge the potential value வந்து kq by r. Okay, r na the distance of separation. புரிஞ்சுதா? And potential due to electric dipole வந்து k p cos theta divided by r square. Again as I mentioned இங்க வந்து r தான், ஆனா dipole, whenever we are talking about dipole இங்க வந்து r square. ஏனா p ல ஒரு l இருக்கு, ஒரு length இருக்கு, அதோட I mean dimension should balance, right? Electric field due to dipole or point charge or whatever be the cases, அது வந்து we are not even talking about it. Okay, ஆனா வந்து dimension வந்து சேமா இருக்கணும். ஏனா we are finding electric field only. And the dimension balance பண்றதுக்காக தான் we are I mean while we are getting this, we are getting a equation like this. Okay, so இப்போ வந்து for an axial line in the potential வந்து we are keeping cos theta as axial line na theta வந்து 0. அப்படினா we will be getting k p P by R square. Equatorial cos theta வந்து 90 degree. So அப்படினா அது வந்து 0. So equatorial potential won't experience. Next வந்து relation between electric field and potential. அங்க இருந்து you can expect a question. அந்த electric field and potential relation வந்து is equal to minus dV by dr, or let's say negative gradient of potential. ஏதாச்சும் quantity we have to divide it with a distance. அப்படினா we will call it as gradient. So இங்க வந்து gradient தான் potential ஓட and அது வந்து opposite direction. So அதனால தான் we are saying E is equal to minus dV by dr. Next one the potential energy, as we discussed, K Q1 Q2 divided by R square. Next one the if we are bringing two charges to an external electric field na, and the total, I mean and the complete scenario da potential energy வந்து Q1 V1. Okay, wherever we are keeping the Q1 charge, அங்க ஒரு potential இருக்கும். ஏன்னா already அங்க field இருக்கு. Okay வா? Next வந்து I am bringing Q2 to a point which is having a potential V2. So அப்படினா we can just say that Q1 V1 plus Q2 V2. இப்போ வந்து two charges இருக்கு. இந்த two charges இருந்துச்சுனா இதுக்குள்ள ஒரு potential energy இருக்கும். அந்த equation also we know K Q1 Q2 divided by the distance of separation. So இதுதான் வந்து potential energy in the external field. Multiple times in the question கேட்டுட்டு இருக்க. So you should know the equation. Next வந்து potential energy of two system we have studied, and இப்போ வந்து we have a dipole. So in the dipole if you are keeping in an external field, what is going to be the potential energy? And the potential energy da minus P dot E, or let's say minus PE cos theta. And எப்பவுமே stable na potential energy minimum இருக்கணும். Okay, stable na meaning minimum. Okay, so அப்படினா in the minimum value will come when theta is equal to 0. Okay, theta will be 0, then we will be getting potential energy which is equal to minus PE. அதுதான் minimum value. Correct? So we can say that when theta is equal to 0 degree, then we can say that in the potential energy when this minimum da, and we can say it is in stable equilibrium. If I am giving theta is equal to 180 degree, what is going to be this value? Minus PE into minus 1. அப்படினா it is going to be plus PE. அப்படினா I can say that இதோட maximum. கரெக்ட்டா? இது வந்து maximum potential energy. அப்ப வந்து unstable equilibrium. And we can, I mean always whenever we are talking about the potential energy, எப்பவுமே we need a reference point. So அந்த reference point தான் இங்க when theta is equal to 90 degree, potential energy will be 0. And the reference point we are taking it as at 90 degree. So next one the equipotential surface, the surface which is having the same potential everywhere, wherever you are checking the potential will be same, and work done moving in a moving a charge is going to be 0 in an equipotential surface. Yena work done oda equation is nothing but Q into delta V. So if it is equipotential in the value வந்து 0 ஆக போற. Electric field is always perpendicular. Let us say this is what our field lines for a positive charge. Correct? இந்த மாதிரி field lines will passes through it. Equipotential na I can say that I'm taking a point over here which is at a distance r, another point here again distance r. So I'm just taking all the points. I can see that the potential will be same at that point. Appadina I can say that in the field and equipotential வந்து always making 90 degree, and in the equipotential surface வந்து it will never ever intersect. Next வந்து capacitance. The capacitance na enna? It is the ability of a conductor to store electric energy in the form of electric field. அதுதான் வந்து இந்த capacitance. So அப்படினா C is equal to Q by V. So Q will be always proportional to V. அப்படினா we can just introduce a constant, and the constant the capacitance. Okay, so capacitance la வந்து we have two different types of capacitors are there. Spherical இருக்கு, cylindrical இருக்கு. ஆனா வந்து we are focusing on parallel plate capacitor. அதுக்கு முன்னாடி I just wanted to tell you one more equation for the that you can just add here. இப்போ வந்து we have an isolated, okay, we have an isolated spherical capacitor na, adoda capacitance வந்து 4 pi epsilon naught r. அது அந்த equation also you can study for a isolated capacitor, and the capacitance வந்து 4 pi epsilon naught r. Next வந்து parallel plate ஓட capacitance வந்து C is equal to epsilon naught A divided by D. A na area, which means இப்போ வந்து I am just keeping two plates. Okay, இந்த plates ஓட shape வந்து anything can be. Okay, இப்போ வேணும்னா rectangular, square, circle, anything will be fine. So இப்போ வந்து area na இந்த surface ஓட area. Okay, இந்த surface ஓட area. Okay, D na இந்த two surface, what is the distance of separation? அதுதான் வந்து D. புரிஞ்சுதா everybody? So that is also important. இப்போ வந்து I'm just keeping a dielectric medium in between the two plates na what is going to be the capacitance? It will increase by k times. So அப்படினா அந்த equation வந்து k epsilon naught times a by d. Okay va? So that is how it will change. And இப்போ வந்து I don't want to fill the complete dielectric medium in between. கொஞ்சம் space மட்டும் தான் இந்த dielectric medium இருக்கு. So அப்படினா I will draw the diagram here. You can just check it out. Okay. So இப்போ வந்து இதுதான் நம்ம parallel plate. இதுல வந்து I'm just keeping the dielectric medium with a thickness t and in the separation வந்து again d. அப்படினா அந்த capacitance வந்து epsilon naught a divided by d minus t plus t by k da and the equation கூட important da. In the sample paper if you are checking it, the question direct ah கேட்டிருக்கு. Next வந்து capacitors வந்து we are going to connect in series and parallel. அப்படினா we will be getting for series 1 by c equivalent which is equal to 1 by c1 plus 1 by c2 plus 1 by c3, and for the parallel combination வந்து it will be c equivalent which is equal to c1 plus c2 plus c3 etc. இப்போ வந்து இது identical na இந்த c equivalent வந்து c by n for series and for parallel it will be n times c. Okay va? Next வந்து energy stored in a capacitor and the equation மட்டும் போதும், it is nothing but half cv square, and you can just substitute c in the relation ல இருந்து you can just substitute and you will be getting the other two equations as well. Next வந்து we are moving to the third chapter, current electricity. So in the current electricity chapter la, whenever you are just looking at this, first வந்து we are starting with electric current. Electric current na flow of charges da. So conductor la வந்து அது free electrons da. So flow of free electrons da in the current, rate of flow of charges. Okay va? So அந்த current oda equation, instantaneous current oda equation வந்து dq by dt, and we can just say that I is equal to q by t. Q ku you can keep it as ne by t. Instantaneous current na you can just write dq by dt. புரிஞ்சுதா? It is nothing but dq by dt. And next one, if you wanted to find charge, you can integrate to get the charge. Okay va? Next one, we are going for the current density. Current density is another term. The current per unit area வந்து இந்த current density da. So அந்த current density வந்து vector quantity, ஆனா current வந்து scalar quantity. Why current is considered as a scalar quantity? அது வந்து vector algebra follow obey பண்ணல, அதனால தான் அது வந்து considered as a scalar. ஆனா வந்து current density க்கு வந்து direction இருக்கு. It is same as the direction of area vector. So இது வந்து I by A. Okay, next one, you should know this equation also, J which is equal to nq into vd. Vd na drift velocity na enna? The average velocity when the electrons are under the, or let's say whenever we are applying external electric field, அந்த டைம்ல electrons-ஓட velocity தான் இந்த drift velocity. அதோட order வந்து 10 to the power minus 3 meter per second. And also அந்த drift velocity expression வந்து EE, okay, charge into the electric field into the relaxation time divided by m, mass of the charge, or let's say electron in this case. Next வந்து I and VD relation, அது derive பண்றதுக்கு கூட கேட்கறதுக்கு chance இருக்கு. I is equal to n into A into VD into E. Okay, and the equation we should know. Mobility na very simple, and the magnitude of drift velocity divided by electric field da in the mobility. Adukku vanda if you are just putting drift velocity equation, then you will be getting the mobility as E tau by m. E will be get cancelled. Next vanda Ohm's law. Ohm's law na enna? Yes, whenever the physical conditions are constant or temperature is constant, in the potential difference வந்து proportional to current. அப்படினா we can say V is proportional to I, and we are introducing a constant, and the constant da R. Okay, and the R na enna? The resistance, correct? It will oppose the flow of current. That is what we are calling it as resistance. And the resistance oda equation வந்து rho into L by A. Okay, rho into L by A. So we can just say that rho into L by A, rho na this resistivity. L na the length of the conductor, A na area of the conductor. Next one in the resistivity or microscopic form of Ohm's law, adha the J is equal to sigma E. Adala vandu you should know rho value, or let's say this 1 by sigma value, which will be coming as m by n e square to. Yena idu basis idoda basis la da we are discussing about the temperature dependence. So in the equation kuda important ah irukku. Next vandu we have mentioned conductivity vandu 1 by rho, vector form vandu J is equal to sigma E, and in the temperature dependence vandu rho or R same relation da, R is equal to R naught into 1 plus alpha delta T. Alpha na in the temperature coefficient da, and the temperature coefficient vandu positive for the metals or conductors, and adu vandu negative for the semiconductors, negative or almost zero for the insulators. Next one, the cells and EMF, cells, EMF and internal resistance. So cell now we know that it is a device which will be converting chemical energy, right? Chemical energy to the electrical energy. The cell is a device which is converting chemical energy to electrical energy. Enna vida you know better about this cells, correct? You are studying in chemistry chapter, correct? Okay, so cells na in the device which is used to convert chemical energy to electrical energy. And next one, the EMF na very simple. The potential when it is a open circuit. Open circuit na there is no current flow. In the current flow illata, if there is no current flow, and the time la irukra potential da in the EMF. Ipo the current, it is a closed circuit. Appadina the current will start flow. Appadina if it is closed surface and current started flowing through the circuit na, we can say that and the time la irukra potential across the cell, or let's say the potential drop da nothing but the terminal voltage. அதுக்கு இம்பார்ட்டன்டான ஒரு ரிலேஷன் இருக்கு. V is equal to E minus IR. Okay, R na internal resistance. Internal resistance na ipo vandu in the cell or battery, whenever you are opening it, you can just see that inside that there is an electrolyte, there is 2 electrodes. So ipo vandu in the charges will it travel inside the cell also. Okay va, in the charges vandu it will travel inside the cell also. And the time la, and the inside flow la, and the time la when it is traveling through the electrolyte, and the electrolyte vandu konjam resistance, it will provide some resistance. So and the resistance, the internal resistance, the resistance provided by electrolyte is known as the internal resistance. Ipo vandu we are connecting this cell in series and parallel na. Series la வந்து simple da, equivalent EMF கண்டுபிடிக்கிறதுக்காக you can say epsilon 1 plus epsilon 2 etc. and R equivalent வந்து R1 plus R2 etc. Next வந்து parallel you can just write the equivalent EMF divided by R equivalent, which is equal to EMF E1 divided by R1 plus E2 divided by R2 etc. Next one, the important thing, the Kirchhoff law. Adula vandu first junction rule na the current entering to the junction and leaving the junction one the same. Okay, so which means on the junction la irukra current vandu 0. Next one, the loop rule na enna, the total potential difference in a closed loop that will be coming as 0. Okay, so appadina I can say that in the junction rule vandu conservation of charge, the charge coming to the junction, leaving the junction same, charge conserved. Ipo in the loop rule vandu it is a conservation, it is representing the conservation of energy. Ena we have given some voltage, correct? We have given some voltage, and the voltage is used by all the resistors or the devices in the circuit. Okay, and the voltage is completely used. We have given, it is utilized completely. So we can say that loop rule vandu the total potential difference or total delta V is coming as 0. Okay, in a closed loop. Next one, the Wheatstone bridge da, and the condition you should know. So on the diagram vandu ippadi irukum. So this is how it looks. Okay, so ipo vandu we will be giving a potential difference over here, and we will be having a galvanometer over here. So idu da R1, this is R2, this is R3, and this is coming as R4. Appadina I can say that R1 by R2 should be equal to R3 by R4. Appadina I can say that the Wheatstone bridge is balanced. Then we can find any of the, if we don't know any of the resistance, to find the unknown resistance we can use the Wheatstone's bridge. It is also how we are finding this, we are applying the Kirchhoff law rules only. Okay, next one we are going for the moving charges and magnetism. இப்போ வந்து moving charges and magnetism ல first we will be discussing about the Biot-Savart law. Biot-Savart law na enna, we have a current carrying loop. Okay, so on the loop nala we will feel a magnetic field. Adu vandu directa we cannot find. We can find small, we can take few small elements, current elements, and the each current element will be giving a field that is equal to dB. And the dB da either mu 0 by 4 pi. Wherever we have written 1 by 4 pi epsilon naught there, here we will be writing mu 0 by 4 pi. Purinjada? So you can just compare all the equation and you can study these two chapters together in a single stretch. So mu 0 by 4 pi IDL cross R vector divided by R cap. If you are writing it as mu 0 by 4 pi IDL cross R cap na, in the denominator la what it will come? R square. புரிஞ்சதா? Okay va? So இப்போ வந்து we are going for the permeability of free space oda value வந்து mu naught oda value வந்து 4 pi into 10 to the power minus 7 and adoda values வந்து if you you have to study those values as well because yena it is not confirmed that you will be getting in the question that value will be there, we don't know. Okay va? So adanaala you have to study these values as well. So இப்போ வந்து Ampere circuit law da another important law, அது வந்து closed loop. Okay, இப்போ வந்து I have a current carrying wire. இது வந்து I'm just considering inside a closed loop. Gauss's law la vandu what we have done? Gauss's law la vandu what we have done? We have considered a Gaussian surface, correct? So அப்படினா இங்க what we are doing? We are considering a closed loop. அது வந்து we are calling it as Amperian loop. Okay va? So இந்த Amperian loop ல இருக்கிற current carrying wire இருக்கு. So அப்படினா I can say that the closed line integral B dot dl will be equal to mu 0 times the current enclosed in the Amperian loop. Next one, we should find the field due to current configuration. We have an infinite long wire. Appadina we will use this Ampere's law only and we will be get it as mu 0 I divided by 2 pi r. Okay va? R na sonna the radius. Okay va? Next one the circular loop. The circular loop ku vanda we can say mu 0 n I divided by r at the center and it is along the axis. Ippadi da in the circular loop. Okay, so center la value da we have mentioned right now. So ipo vandu we need to find the field at a point x from the center along the axis. Appadina and the value vandu mu 0 n I r square divided by 2 into r square plus x square all raised to 3 by 2. So you should know that value as well. Ipo vandu solenoid na nothing but mu 0 n I. So n na enna? The number of turns per unit length. So depending upon the question you can just substitute that as well. Next one the force வந்து first you should know the magnetic force. Magnetic force na enna? Tell me what is magnetic force? The force due to the when a charge is entering to a magnetic field it will experience a force and the force the magnetic force. Okay, adoda value வந்து q into v cross b. V na velocity, b na magnetic field. Okay va? So இப்போ வந்து we got it that is equal to q into v cross b. அப்படினா we should know what is Lorentz law. Lorentz force. Okay, Lorentz force na enna? When this charge is entering to electric and magnetic field adukku vandu it will experience a force due to electric field as well as due to the magnetic field. So on the electric field nala vanda force the QE, magnetic field nala q into v cross b. Adoda sum the Lorentz force. Purinjada? Next vandu we are projecting a particle, okay, in a magnetic field. Appadina if it is in the same direction, parallel or anti-parallel, adukku force experience agadu ena theta vandu 0. Okay, v cross b vandu 0 agapore. Appadina it will move in a straight line. Next one, let us say if you are just projecting perpendicular to the surface na anga adukku it will exhibit a circular motion and the circular motion oda radius vandu mv by qb. Purinjada? And next one we can go for the force on a current. Ipo vandu we have discussed about a charge, correct? So ipo vandu I just wanted to know in the road illana oru conductor irukku adula irukra force adukku experience agara force da we need to know. Adu nothing but bill. Just remember bill na enna? B for magnetic field, I na current, L na in the length of the conductor, and always in the length of the conductor and current R we will take in the same direction. Next one the force between two parallel currents, adu vandu F divided by force per unit length which is equal to mu 0 I1 I2 divided by 2 pi d. D is the separation between them. I1 is the current which is passing through the first one, I2 is the current in the second one. Next one, the torque and galvanometer. So torque, if you are just keeping a rectangular or let's say coil in between a strong magnet, அப்படினா அங்க இருக்கிற torque என்ன இருக்கும்? It is nothing but m cross b or let's say NIAB sin theta. And whenever we are talking about the moving coil galvanometer, we will use the cylindrical magnet that will give always this what is it? The magnetic moment and magnetic field வந்து always perpendicular ஆகிறதுக்கு தான் we have given that field. ஓகேவா? சோ அப்படினா அந்த மேக்ஸிமம் டார்க் வந்து NIAB தான் அந்த மேக்ஸிமம் டார்க். ஓகேவா? சோ இந்த மூவிங் காயில் galvanometerல it will experience a restoring torque. அந்த restoring torque வந்து I'm just representing it as K5. Okay, so அப்படினா we can just equate NIAB which is equal to K5. So now you can just make a relation of this deflecting angle is nothing but proportional to the current flowing through the circuit. அதுதான் இதோட principle. Okay, so principle வந்து very simple. Whenever we are keeping a coil inside a external field, it will experience a torque. Okay, அதுதான் இதோட principle. Next வந்து current sensitivity. So we are just we will be finding theta by or let's say phi divided by I. அதுதான் current sensitivity. If you are finding phi by V na, you can go for voltage sensitivity. Again, I'm telling you guys, if you want this PDF, in the description box ல அதுக்கு link இருக்கு. So அந்த link you can just check it out. You can download it directly. So you can just go through the PDF. Next வந்து conversion da. If we need to convert galvanometer into ammeter, we will connect a shunt resistance. Correct? So அந்த shunt resistance oda value வந்து IGG divided by I minus IG. Capital G na the resistance of the galvanometer. IG na the current which is passing through the galvanometer. Next வந்து to convert to voltmeter na, we can say it is nothing but we are adding a resistance which is nothing but V by IG minus G. ஓகேவா? புரிஞ்சுதா? சோ இதுதான் வந்து மூவிங் சார்ஜஸ்ல இருக்கு. நெக்ஸ்ட் வந்து magnetism and matterல first வந்து we are going to study about the magnetic moment. Already we have used in the previous case. Okay, when we were discussing about the torque, we already discussed. So இங்க வந்து we are discussing about that magnetic dipole na nothing but the poles in the poles and they are separated by a distance. So adudha anga electric dipole, inga magnetic dipole. So inga vandu we can say that the charge into, or let's say we used to say not charge, it is the pole strength. Okay, so we can say that in the magnetic moment vandu it is nothing but the pole strength into the distance of separation. Okay va, pole strength into distance of separation. Again here also you might have studied 2D, 2 times D na அந்த D வந்து சென்டர்ல இருந்து இந்த one போலுக்கு அந்த distance தான் D. Next வந்து torque வந்து m cross b தான். Okay, m cross b na mb sin theta. Potential energy வந்து minus m dot b or minus mb cos theta. Next வந்து stable equilibriumத்துக்காக இந்த theta வந்து 0 degree, same as what we have discussed over there. Okay, and unstable equilibriumத்துக்காக இந்த theta வந்து 180 degree ஆக போற. And next வந்து we should go for the Gauss's law. Gauss's law என்ன இருக்கு? Gauss's law வந்து very simple. We know that we are always keeping a magnet, okay, magnet inside a Gaussian surface na, அதுல வந்து the field lines going out and coming inside வந்து same தான். அப்படினா there is no net flux. So then we can say that and the closed integral b dot ds வந்து 0 ஆக போற. புரிஞ்சுதா everybody understood? இதுதான் வந்து Gauss's lawல. நெக்ஸ்ட் வந்து இந்த equations வந்து you should study very well. ஏனா இது வந்து டைரக்ட்டா கேட்க போற. Nobody is going to ask you some difficult or let's say confusing question from it. At least you should know the equation na. இதுல இருக்கிற எல்லா questionsuமே you can do it easily. Okay va? So magnetization இருக்கு. magnetization na the magnetic moment per unit volume da. Next வந்து magnetic intensity, அது வந்து H is equal to B by mu naught minus M. Then susceptibility equation, relative permeability and total field. இந்த equations எல்லாம் வந்து important தான். கரெக்ட்டா you can just write and you can study. ஏனா அது வந்து important and that can give you a straight mark. Okay, டைரக்ட்டா கேட்க போற, so you can get the marks easily. So next வந்து magnetic properties தான். So we know diamagnetic material இருக்கு, paramagnetic material இருக்கு and ferromagnetic material இருக்கு. So இதுல வந்து we know this chi value வந்து small and negative for the diamagnetic and paramagneticல வந்து positive, a small positive தான். Ferromagneticல வந்து அது வந்து it is going to be large and positive. And we know in the chi and mu r relation, so we know that we know that idoda relation vandu 1 plus mu r da in the equation, so we can just say that 0 less than or equal to mu r less than 1. If you know the relation, you can just go for this. And in the temperature dependence vandu in the diamagnetic is not depending upon the temperature, paramagnetic vandu it is inversely proportional to temperature, and ferromagnetic vandu decreases with the temperature. Okay va, so you should know the temperature dependence also. Next one, the electromagnetic induction. So adula vandu first we will be talking about the magnetic flux. As we discussed about the electric flux, as same we can go for the magnetic flux as well. So it is nothing but the magnetic field lines passing through the surface perpendicular to the surface. Adoda value vandu ange E dot A irundha inge B dot A. Okay va, so BA cos theta, இது வந்து non uniform na, we can say it is nothing but B dot ds. புரிஞ்சுதா? So இப்போ வந்து first we are going for the Faraday's law. Faraday's law na very simple. If there is a flux change, என்ன ஆக போற? Flux change இருந்துருச்சுனா we can say that there will be a induced EMF will be produced. So அப்படினா we can say that induced EMF will be equal to minus d phi by dt. Okay, so in the Faraday's law la he has given the magnitude of the induced EMF, ana and the direction he didn't give any idea about it, and the direction we got it from the Lenz's law. So ipo vandu in the PDF, if you wanted, you can just get it from the description box, and the description box la irukra first link open panna podum, you will be getting the you can download the PDF. Okay, marakama download panniko, yena you can just go through in the last minute preparation la you can go through this, and that will help you in the examination time. Next one, the Lenz's law da, always in the induced EMF vandu it will oppose the change in flux. Okay, adanala we can say that in the induced EMF which is equal to minus n delta phi by delta t. Next one, the motional EMF. So let us say if a conductor is moving in a external magnetic field, the charges will also experience a magnetic force. Adanala we can say that there will be an induced EMF, and the induced EMF da BLV, B in a magnetic field, L in a length of the conductor, and V na the velocity. Okay va, next one, the if it is a road, okay, if it is a road na, if it is a road and it is rotating, அப்படினா in the induced EMF வந்து it will be half B omega L square. புரிஞ்சுதா? L square na L, this length of this thing. Self induction na, let us say current is passing through a coil, and the coil la innum we know induced EMF will be produced. Correct, induced EMF will be produced in the coil. அப்படினா again in the induced EMF will resist the change in flux. Okay, so other what we are calling back EMF. So in the induced EMF is produced in the same coil, adha vandu self induction, adoda relation vandu induced EMF will be equal to minus L di by dt. Okay va, so for a solenoid in the inductance, self inductance, L na self inductance, adu vandu mu 0 n square A divided by L, and we can also say mu square n square A into L. I mean the small n is nothing but number of turns per unit length, so you can just replace it. So next one, the energy stored da, so the potential energy will be equal to half into Li square da in the energy stored. Energy density vandu mu B square divided by 2 mu naught da. Next one, the mutual induction is nothing but current is passing through one coil, and due to the current flow there will be a magnetic field, and the magnetic field used panni there will be a flux change will be happening in the secondary coil, mutual. Okay va, so அந்த மாதிரி I mean one coil la in the current is flowing, second coil la induced EMF is generated, and the process the mutual induction. So adoda expression vandu induced EMF which is equal to minus m dip divided by dt. Ip na the primary, the current which is giving in the primary circuit. Next one, the mutual inductance of solenoids, adu vandu important da, m which is equal to mu naught n1 n2 a divided by L. Next one, the coefficient of coupling na, let us say we are keeping this solenoids like this. One is here, another one I'm just keeping inside. So this is what we are calling coaxial. So inga vanda if any of the solenoid we are giving the current, so the magnetic field lines will passes through the second one completely. So it is a complete induced EMF will be produced, utilized properly, right? In the field lines complete use panna pore. Ana vandu one solenoid is like this, another one is like this. So in the field lines complete idukku kadakka maata. So adanala da we are saying the coefficient of coupling. Okay, how it is aligned. So adoda or relation irukku, m is equal to k into root of L1 L2. So ipo vandu if it is coaxial, then we can say in the k value vandu 1 ta. next வந்து AC generator. AC generator ஓட principle வந்து mutual induction தான். ஓகேவா? So AC generatorல induced EMF will be produced. Induced EMF will be coming as epsilon naught sin omega t and peak EMF வந்து NBA omega. So AC generatorல we know that there will be a rectangular coil. So adula vandu it will experience a torque and there will be a field lines also. Flux change will happen. So electromagnetic induction induction da idoda principle. Okay, AC generator oda principle. Next one we are going for the next chapter, alternating current. Okay, alternating current na definitely we can say one thing. Alternating current na in the magnitude direction everything is changing in every second. Next one the RMS value na, let us say we have a DC source, we have an AC source. So in the DC source la voltage, current ellam calculate பண்றதுக்கு easy da. So what we will do, we will give the current or potential over there and we will make the heat produced as some x joules. And at the same time la we can measure the heat developed in the AC source. So அந்த டைம்ல இதுல வந்து 100 joules, let's say it is 100 joules, இதுல கூட 100 joules ஆச்சு. So corresponding voltage and current in the DC source will be known as the RMS value of the AC source. அதுதான் வந்து RMS value. அதுக்கு வந்து we will be finding the peak value divided by root 2. So in the ammeter எல்லாம் we are finding the RMS value only. So VRMS into VB by root 2. Then average half cycle la current oda value வந்து 0.637 into the peak value. We are just giving the value of 1 by root 2. That's it. Next one we have the pure inductive resistance and the capacitive circuit. So adala vandu first inductive reactance we should know. So reactance na it will oppose. If there is a current flowing through the inductor will provide a resistance and the resistance are inductive reactance. Adoda value vandu XL which is equal to omega L which is equal to 2 pi FL. புரிஞ்சுதா? next வந்து capacitive reactance. இந்த capacitance also will give some sort of resistance and the resistance da XC which is equal to 1 by omega C which will be coming as 1 by 2 pi FC. next வந்து impedance da, if you have a connected inductor and capacitor and resistor அந்த circuit oda impedance da root of R square plus XL minus XC the whole square. and இப்போ வந்து phase angle தெரியணும்னா we can just go for XL minus XC divided by R. so இப்போ வந்து you should know the impedance triangle as well. So ipo vanda this is how we have this impedance triangle over here. So இதுதா வந்து 5, this is Z and this is what XL minus XC, இது வந்து R. So அப்படினா cos 5 வந்து R by Z. Okay, so அந்த relation கூட you should know. next வந்து resonance in the LCR circuit da, when XL is equal to the inductive reactance is equal to the capacitive reactance, then we will call it as resonance. So அந்த டைம்ல வந்து இந்த impedance வந்து minimum ஆக போற. So we can just say that அந்த time L omega will be equal to 1 by C omega. So you can just put omega value as 2 pi f. So we will be getting omega naught and the resonant frequency வந்து 1 by root LC and the frequency வந்து இது வந்து angular frequency வந்து you can say 1 by 2 pi into 1 by root LC. So அதுதான் வந்து value. Okay வா? next வந்து the power factor வந்து R by Z we already saw that and the average power or let's say true power or real power வந்து VRMS into IRMS into cos phi da. so இதுல வந்து power loss will be happening only in the resistance circuit, only due to resistance only we have the power loss. so அதனால அந்த டைம்ல வந்து cos phi வந்து 0 ஏனா V and I is in phase, so அது வந்து 0. ஆனா capacitive and inductive circuit ல வந்து it is going to be 90 degree, அதனால there is no power loss in the capacitive and inductive circuit. okay, next வந்து wattless current da. wattless current வந்து it is not mentioned. wattless current வந்து again very simple concept da. இப்போ வந்து we know the current which is the power loss due to the resistance circuit or through the resistance. அந்த மாதிரி even there is a current is flowing through inductor and capacitor, ஆனா வந்து அங்க power loss heat loss இல்ல. so அதனால we will call it as அந்த current வந்து we will call it as wattless current. okay வா? so அதுதான் அதுதான் வந்து வாட்லெஸ் கரண்ட். நெக்ஸ்ட் வந்து டிரான்ஸ்ஃபார்மர்ஸ் தான். டிரான்ஸ்ஃபார்மர்ஸ் ஆர் ஒர்க்கிங் அண்டர் த பிரின்சிபல் ஆஃப் மியூச்சுவல் இண்டக்ஷன். பிரைமரி காயில்ல we will be giving the voltage and secondary coil induced EMF will be produced due to mutual induction. So adula வந்து we can just have a relation Vs divided by Vp which is equal to Ns by Np which is equal to Ip by Is. So அந்த relation வந்து important தான். For an ideal transformer the input power will be equal to output power. அதனால தான் Vp Ip which is equal to Vs Is. Next வந்து step upல வந்து இந்த secondary number of coils in the secondary will be more. ஏனா we need more voltage in the secondary. ஆனா வந்து step downல வந்து secondaryல less ஆக போறேன். So next வந்து wave optics. Let us go for wave optics. Okay. Next வந்து ray optics இருக்கு, அது வந்து lastல இருக்கு. So we can just discuss later. Okay. So இப்போ வந்து wave optics ல first வந்து we will be discussing about the wavefront. Wavefront னா என்ன? Wavefront னா என்ன? It is nothing but the collection of, okay, it is nothing but the collection of all the all the particles which is vibrating in the same phase. Adha vanda in the wavefront. Okay, next vanda we should know the Huygens principle. Huygens principle what he is saying. So each, I mean we know that it will be producing wavefront. Each wavefront la primary wavefront la over pointum it will act as a secondary source. Okay, and the secondary source la it will be developing secondary wavelets. And the secondary wavelets oda speed வந்து same as the primary wavefront. And இப்போ நீங்க வந்து இதுல if you are giving the the tangent for this wavelet, secondary wavelets na, that will give you the secondary wavefront. Okay va. Next வந்து interference, அதுல path difference வந்து delta x which is equal to yd by capital D. Then constructive interference oda condition வந்து இந்த path difference n lambda இருக்கணும். Destructive interference oda vandittu vanda we can just say the odd multiple of lambda by 2. Next one the fringe width that will be coming as lambda d by d. Okay, so next one the diffraction single slit da adoda condition maximum oda condition, sorry, minimum oda condition vandu n lambda a sin theta, adha vandu path difference. For a small angle we will take it as a theta which will be coming as n lambda. Okay va, adu vandu minimum oda condition. Inga vandu n lambda na maximum oda condition. Next one the width of the central maximum will be double of the first after the central maximum we will be having the first bright band. So adoda band oda 2 times the central maximum. So next one the dual nature. The dual nature la first one you should know the minimum energy, the work function one the minimum energy required for an electron to escape. Correct? So ipo vandu you can just tell about photoelectric effect. Enna photoelectric effect enna? So light with the suitable frequencies falls on a metal surface. So due to getting that energy from the light, the electrons will start emitting, or let's say it will escape from the metal surface, and the process the photoelectric effect. Okay va. So next one the we should know in the photoelectric effect experiment la vandu we have observed few things. Intensity, current and intensity vandu proportional irukum. Ena intensity increase aachuna number of photons vandu increase agum. So each photon will interact with only one electron. So adanal one photon brightness increase aachuna one electron one photon. So brightness increases, number of photon increases, number of electrons emitted increases. Appadina in the current flow means in the flow in the current oda flow charges oda flow in the current, appadina we can say intensity increases na current increases. Stopping potential is only depending upon the energy, or you can just say directly proportional to the frequency. Okay, and threshold frequency vandu it is nothing but we have mentioned about the work function na, it is nothing but h mu naught. So h mu naught na h na the constant value da Planck's constant 6.6 into 10 to the power minus 34. Appadina I can say that the work function வந்து கம்ப்ளீட்டா டிபெண்ட் பண்றது இந்த frequency தான். அந்த மினிமம் ரிக்வயர்ட் frequency தான் இந்த threshold frequency. அந்த மெட்டல்ல இருக்கிற எலக்ட்ரானுக்கு எவ்வளவு எனர்ஜி வேணும், ஓகே, அந்த எனர்ஜிக்காக எவ்வளவு மினிமம் the required minimum frequency தான் இந்த threshold frequency. and இது வந்து instantaneous process தான். இந்த processக்கு 10 to the power minus 9 seconds மட்டும் தான் எடுக்குது. it will take. next வந்து ஐன்ஸ்டைனோட photoelectric equation தான். அது வந்து h mu, the energy of the photon will be splitted for the work function plus the kinetic energy, and we can also say இது வந்து equal to EVS. Okay va. Next வந்து matter waves க்கு wavelength இருக்கு, அது வந்து h by p. So h by p na h by mv, lambda is equal to h by root 2 mk, and k also you can just replace it as ev, charge into the potential difference. So next one we are going for atom. So atom we are going for the first experiment, alpha particle experiment, and the experiment learned we understood most of the particles were without deflection it was passing, which is indicating the atom வந்து majority space வந்து empty da, and few வந்து retrace its path. So அதனால வந்து அங்க வந்து ஒரு positive strong positive இருக்கு, அதுதான் வந்து we are calling it as nucleus. So இதுல வந்து we should know few things. Distance of closest approach, அது வந்து it will be 2z d square divided by 4 pi epsilon naught k. Next வந்து impact parameter. Impact parameter na let us say இதுதான் நம்ம nucleus. Okay, so இதுதான் in the center, the line which is passes through the center. இப்போ வந்து இந்த alpha particle is coming like this. Okay, so அப்படினா இதுதான் இந்த initial velocity ஓட direction. Initial velocity ஓட direction. In the distance, in the perpendicular distance between the center line of the nucleus and the initial velocity direction, அதுதான் வந்து இந்த impact parameter. Then quantization condition L is equal to mvrn, which is equal to nh by 2 pi, and frequency condition வந்து h mu will be equal to the change in energy. Next வந்து radius ஓட relation, you should at least know the proportionality relation. Rn வந்து proportional to n square divided by z, and velocity வந்து z by n, அப்படினா energy வந்து z by n whole square, which means z square by n square. In the value you should know the energy will be coming as minus 13.6 n square divided by z square divided by n square, and the value you should know. And kinetic energy வந்து it will be equal to minus of the total energy, and in the total energy and the potential energy relation வந்து potential energy will be 2 times the total energy. Total energy is negative, ஆனா kinetic energy வந்து positive. Next வந்து hydrogen spectrum da, illa Rydberg formula வந்து ரொம்ப important, 1 by lambda which is equal to r into 1 by ni square minus 1 nf square minus 1 by ni square. Next வந்து chapter nuclear, adula வந்து we should know the relation for the radius r is equal to r naught into a raised to 1 by 3. adula வந்து r naught oda value வந்து it is coming as 1.2 femtometer, so you can just go for 1 into 10 to the power minus 15 also will work. Density வந்து it is independent of a, it is not depending upon the mass number. Then mass defect வந்து mass defect na in the product oda we will check the reactants oda mass and product oda mass, அதோட difference da in the delta m, and the delta m and the mass வந்து energy convert ஆச்சு for binding. Okay, for binding, so அதனால binding energy வந்து delta m c square da, and binding energy per nucleon and the part and the graph வந்து important da, so you should go through it. Next வந்து nuclear reactions, fission and fusion. Fission na என்ன, heavy nucleus is unstable, so அதனால அதுக்கு வந்து it should come to the stable state, அதனால it will split, அதுதான் வந்து fission. Fusion na என்ன, the lighter nucleus வந்து unstable, அதுக்கு வந்து stable ஆகிறதுக்கு it will combine and it will come to the stable state. Next வந்து semiconductor da. Semiconductor what is happening, valence band இருக்கு, conduction band இருக்கு, energy gap இருக்கு. So valence band na என்ன, the energy level of the valence electrons da, and conduction band na என்ன, it is nothing but the energy of the electrons which is in the the free electrons இருக்கிற space da in the conduction band, அதோட energy வந்து it is more than the valence band, and இதோட basisல da we are just segregating semiconductor, conductor and insulators. இப்போ வந்து it is more than 3 electron volt na we will call it as insulator, less than 3 electron volt na we will call it as semiconductor, and if it is overlapped each other then we will call it as conductor. Next வந்து intrinsic and extrinsic semiconductor. Intrinsic na it is pure, okay, silicon na silicon only, germanium na germanium. Okay, adula வந்து number of charge carriers வந்து equal இருக்கும், electrons and holes வந்து same ஆ இருக்கும். Next வந்து extrinsic na doped one, we add impurity to improve the conductivity. So அதனால வந்து we have two type, n type and p type. n type ல we are adding more electrons, so அதனால pentavalent da, and p type na positive which means trivalent da. So அதுல இந்த n type ல வந்து n negative which means more number of electron as charge carriers, majority charge carriers வந்து electron da, and very few holes will be there. And p type ல வந்து majority charge carriers வந்து holes da, and mass action law வந்து the number of the concentration of free electrons and into the concentration of the holes வந்து equal to the ni square. It is valid all the time. Okay, next வந்து pn junction diode. So அதுல வந்து forward bias இருக்கு, reverse bias இருக்கு. இந்த forward biasல இந்த depletion layer வந்து it is going to be very less. If you are giving more potential, the charges will start flow from each other, each space. Reverse biasல வந்து இந்த depletion layer வந்து increase ஆக போற. So அதுல at some point what will happen, suddenly இந்த diode வந்து damage ஆக போற அந்த particular voltage that we are calling it as the breakdown voltage. Okay, and next வந்து dynamic resistance இருக்கு, அது வந்து delta V divided by delta I. Next வந்து we have half wave rectifier as well as full wave rectifier. So இதுல வந்து half wave and full wave rectifier na we can say that it is nothing but we have one transformer and we have one diode. அது வந்து it will be giving the positive, the output as a positive half cycle. And in the full wave rectifier la அதுல வந்து efficiency double ஆ இருக்கும், frequency double ஆ இருக்கும். So அதுல வந்து we will be getting the even negative half cycle also becomes positive. It will make it in a single direction. So அதுல வந்து if you need to remove the ripples, you can use the capacitor. Again I'm telling you, if you wanted to get the PDF, you can check it on the in the description box adile irukum. So you can just check it and you can go for it. Adu vandu romba important ana thing da. You should remember the formulas, you should remember all the laws, definitions, everything. So in the madri quick revision vandu romba helpful ah irukum. Next vandu electromagnetic waves, adula vandu first we should study the displacement current. So the current is which is arising due to the electric flux da, adoda value vandu epsilon naught into d phi E divided by dt. Next வந்து Ampere Maxwell law, அதுல வந்து instead of mu 0 I, we are rearranging or we are rewriting I as ID plus IC. ID na displacement current, IC na what is nothing but the conduction current. Okay va. So next வந்து Maxwell equation is there. So Gauss's law, closed integral E dot dA which is equal to Q by epsilon naught, and magnetic வந்து 0. Faraday's law it is going to be closed integral E dot dl which is equal to minus d phi by dt. Next வந்து Ampere Maxwell law, that is what we have discussed. Next வந்து இதுல வந்து properties of electromagnetic waves la you should know the relation C is equal to 1 by root of mu naught epsilon naught, and the value da 3 into 10 to the power 8. Next you should know in the E naught by B naught oda ratio வந்து it is nothing but C. So this will help you to find some of the questions already in the sample question paper also we are applied this thing. Then next one this momentum வந்து in the energy divided by C da. Electromagnetic spectrum வந்து important da, adoda application வந்து you should study, there is no other choice. And in the PDF kaga you can just check it on the description box, adile irukku, you can just click on the first link and that will help you to to improve your performance. Next one the ray optics and optical instruments da. So idla vandu first we will be discussing about the mirror formula. I'm not going for the basic laws of reflection and everything. Adula vandu incident angle will be equal to reflected angle da. Mirror formula la vandu 1 by V plus 1 by U which is equal to 1 by F da. Next vandu magnification or equation vandu minus V by U. Next vandu focal length R by 2. Next refraction la Snell's law irukku, N2 by N1 will be coming as sin I by sin R, and that for finding refractive index we have some other equation. For absolute refractive index it is nothing but C by V. So we can say N2 by N1 will be coming as V1 by V2. Also we can just connect with real depth divided by apparent depth. Okay, apparent depth also. So these are the equation. Next one the refraction on a curved surface, adu vandu N2 minus N1 by R which is equal to N2 by V minus N1 by U. Next one the lens maker's formula, adu vandu 1 by F which is equal to N minus 1 into 1 by R1 minus 1 by R2. Thin lens formula vandu 1 by F is equal to 1 by U minus 1 by V minus 1 by U. Next one the power power is nothing but 1 by F, adu வந்து மீட்டர்ல இருக்கணும், இல்லனா 100 by F தான். Okay, and அதோட யூனிட் வந்து diopter தான். Combination, if you are combining the 2 or 3 lenses, the power வந்து you can just add P1 plus P2 etc. Refraction through a prism, adula vandu minimum deviation condition vandu important, the I will be equal to E and R1 will be equal to R2, and the refractive index vandu sin A plus delta M divided by 2 divided by sin A by 2. Next vandu optical instruments la microscope, simple microscope irukku, compound microscope irukku, astronomical microscope irukku, sorry telescope irukku. Adula simple microscope la near point na adoda magnification vandu 1 plus D by F. Okay, ipo vandu infinity la illena we can say normal adjustment na அதுல வந்து d by f. ஓகேவா. நெக்ஸ்ட் வந்து காம்பவுண்ட் மைக்ரோஸ்கோப். காம்பவுண்ட் மைக்ரோஸ்கோப்புக்காக இந்த மேக்னிஃபிகேஷனுக்கு you can just study this equation mo into me. So mo will be always v naught divided by u naught. Me na and the condition depending upon the condition it will change. Near point na it will be 1 plus d by fe. If it is in far point or let's say at infinity na it will be d by fe. Adha change. Next வந்து astronomical telescope, அதுல வந்து magnification is coming as minus f divided by Fe. So we can just say the length of the tube வந்து F4 plus Fe. இதோட diagram வந்து important தான் இந்த question. இந்த question வரதுக்கு there is a lot of chance as well. Again I'm telling you, இப்போ வந்து if you need this PDF, you can just check it out in the description box. அதில் இருக்கு, you can just check it, you can just get it, and also இது வந்து it will be very very helpful for your future preparation. ஓகேவா? So இந்த கொஞ்சம் hours மட்டும் தான் இருக்கு, அதில் வந்து smarta if you are performing, you can get the good score. So அதனால you should study this very very well. Go through the PDF, that will help you. And ஏதாச்சும் doubts, ஏதாச்சும் concern இருந்தா you just give me a comment, okay?